Hi, I'm Dylan Hicks, and together with Chen Yang, Xiaolei Du, Chao Shuo Yao, we built a DIY fixed-wing UAV for ecosystem monitoring. As a bit of background, ecosystem monitoring is vital to tracking changes in our constantly evolving world. This type of monitoring is oftentimes done using UAVs, specifically quadcopters. Our group has used the Phantom 4 quadcopter to capture imagery and track coastal forests. However, on our recent survey in Jamaica, we experienced many issues with such a platform. Quadcopters are not robust enough for the adverse weather conditions experienced in many areas around the world, so we had many issues with the durability of these airframes. In addition, although the images captured from these UAVs are high quality, it is incredibly slow to survey larger areas. To alleviate these issues, fixed-wing UAVs are often used, which are more efficient and robust than quadcopters. However, these UAVs have a very high cost, oftentimes totaling over $20,000. Therefore, we built a low-cost DIY fixed-wing UAV that can capture imagery more reliably and efficiently than a quadcopter, while still maintaining a low cost.
In order to accomplish our goal, we assembled the plane according to the system diagram. We have a camera system that enables flexibility in payloads, with a GoPro as our main sensor and the option to use a Raspberry Pi camera. And then we also have a Pixhawk, which serves as our central control unit. Using telemetry, we can autonomously plan out aircraft courses. Then, there are auxiliary components to the Pixhawk, such as airspeed sensor and GPS unit. Finally, one part worthy to mention is the Raspberry Pi camera module that we created for our survey aircraft. This consists of a Raspberry Pi and a Pi camera. The Raspberry Pi runs a script at startup automatically to get the system ready for pictures at a given interval. After completing the aircraft, we tested out all the motors and servos of the aircraft as shown in the video to make sure everything is functioning. Further adjustments will be made based on the flight conditions. Here's an image of our final plane assembled.
This video shows the first flight of our aircraft. We planned three types of flights. The first one is a maiden flight, which is a full manual flight. The second one is auto-tune flight, which tunes the autopiloting parameters for the third fully automated surveying flight. The full manual flights went well and we proved the capability of the airframe. But when it came to the auto-tune flight, our pilot found that he had nearly no control over the aircraft when the pilot turned on the auto-tune mode, and it caused several incidents like this 90-degree dive shown in this video. We decided to halt the auto-tune flight after the dive, and as a result the third type of flight can be performed. We still need to do more analysis to figure out what caused the failure of auto-tune mode. Although we did not complete all three types of flights and the imagery is recorded all under manual mode, we managed to obtain some really good results after merging the imagery in Agisoft. The resulting imagery from the manual flight, which is not that stable, already guaranteed us with less than 6 square centimeters geo-reference imagery and less than 12 square centimeters DEM imagery.
In conclusion, our fixed-wing aircraft shows its great potential in doing future UAV survey. From our test flights, the aircraft showed a decent survey speed, which is 1/8 square kilometers in just 1.5 minute flight, while Phantom 4 needs 20 minutes to survey the same size area. And our aircraft battery life can support a 15-minute survey, while the Phantom 4 Pro can only do a 20-minute survey. Thus, our plane can more efficiently survey ecosystems than existing quadcopters, while still costing a fraction of other fixed-wing options. In the future, we can use autopilot to enable autonomous flying and test our own custom Raspberry Pi camera system. We hope to continue to improve on our fixed-wing UAV and prove that it can be reliably used as a more efficient alternative to quadcopters and more expensive fixed-wing options. Thank you for watching. If you have any questions, please feel free to contact us via the email address.